Okay, in this short video, we're going to be talking about how we simplify different things besides square roots. So there's different kind of roots. There's cube roots, there's fourth roots, there's fifth roots, there's all kind of roots, okay? Now, we've always done square roots like this. You know, break down square root of 24, and you always find a perfect square that goes into it. So, for example, perfect square that goes into 24 is 4. You got 4 and 6. Which of those can you take a square root of? Well, 4, right? Becomes 2 squared of 6. Now, this is one way of doing it. There's another way I never showed because a lot of times I want you to really understand what it means by a perfect square and make sure you can find a perfect square, okay? Another way of doing this is breaking apart into all of its factors, okay? For example, you can still break this apart into 4 and 6, but what can 6 break down to? Well, 3 times 2. And what about 4? Well, this would be 2 and 2, right? So that means if I have 2 times 2 times 3 times 2, that would give me 24. And it's another way to write this, okay? So now you don't have to do these for square roots, but for higher roots, it may help, okay? Now, it's a square root, so you're actually looking for groups of 2. So there's a group of 2 right there. Now, if that's the case, I'm going to put the 2 on the outside because that's a group that I pulled out. On the inside, you have 2 times 3, which is 6. So it's the same way of doing it, but it's more of a visual way because you're circling actual groups, okay? Now, it works the exact same way with cube roots and fourth roots and all that stuff. You're just circling groups of, well, if it's a cube root, groups of 3, fourth root, groups of 4, so on and so forth, okay? So let's say I have cube root of, I don't know, let's think about it. Let's do 36. Now, this looks weird. Ooh, that looks very odd, but don't worry, it's not bad at all. Let's break down the 36 first of all. We know how to do that. Well, 36 can be broken down with 6 and 6. What can 6 be broken down to? Well, 3 and 2, 3 and 2. All right? Now, you can do this a myriad of ways. You could have done 36 by 12 and 3, right? Either way, you should get these 4 numbers at the bottom. 3, I'm going to put the 3's beside each other and the 2's beside of each other. And just so you know, the bottom of your, I call this a factoring tree, really. The bottom of your factoring tree is what you're going to put inside this cube root in this case. And then the x to the fourth means there's 4 x's. X times x times x times x. Okay? Now what you do is, unlike the last one where we're circling groups of 2, this right here, this number right here is called the index. This tells you how many groups you're going to be circling, okay? So, for example, on this one, I'm circling groups of 3. So, well, let's see. I don't have any group of 3 right here, so I wouldn't pull anything out right here. But I have a group of 3 x's right here. So, in that case, I'd have an x on the outside. And then you have a cube root of, well, then the rest of the stuff stays on the inside. So, in that case, I'm just going to multiply all these numbers together. That would be 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. This right here turns back into 36 because you couldn't pull anything out. And you still have this x inside there. This is how we simplify these down. Okay? It's not that bad. You're just breaking things down and circling groups. Let's do another one like this, okay? We did a cube root. Let's do a fourth root this time. Fourth root of, let's do a fourth root of 64. Whoops, sorry. Let's do some more x's and y's in there. Let's do 64, fourth root of 64, x to the 6th, y to the 8th. Looks hard, but don't worry, it's not bad. Let's break down 64 first, okay? Let's do a different number. Let's do 4, 16. Why not? Doesn't matter what you break it down into. Then this is 2 and 2. Either way, you're going to get 2 and 2 at the bottom here. And right here, you're going to have another set of 2's. 2, 2. So you have 1, 2, 3, 4, 5, 6 2's total. Let's write down 6 2's. 1, 2, 3, 4, 5, 6. All right. And then right here, you have 6 x's. 1, 2, 3, 4, 5, 6, and 8 y's. Ooh, that's a lot to write down. Now, there's a shortcut I'll show you about this in just a minute. 1, 2, 3, 4, 5, 6, 7, 8. But this is really good if you're a visual learner, okay? Let's see. We are circling. Well, this time I'm circling groups of 4 because that tells us how many groups we're circling. Okay. So we have a group of 4 right here. Here's 4 terms, 4 numbers here. So we know we're going to have a 2 on the outside. Let's see. A group of 4 x's. Let's see. 1, 2, 3. There's a group of 4 x's. So we know we're going to have an x on the outside. And then we have a group of 4 y's right here. And another group of 4 y's right here. Now, when you have this, you have 2 groups of y's, right? So in that case, don't write 2y, write y squared. And the rest of the stuff kind of falls into place. You still have this fourth root right here, and you still have all this other stuff that I didn't circle left on the inside, okay? You have this, and that's it. 2 times 2 is 4, okay? X times x is x squared. And that's it. let's do some bigger numbers here where you have some more things to break down. Now, I'm not going to do a fifth root because it's the same idea. All you're doing is circling groups of, well, in that case, if it's a fifth root, you'd be circling groups of 5, okay? Let's do something high. Let's do a bigger number than that. Let's do something like this. Let's keep it with, let me think. Let's try to think of what could work really nicely. Let's do cube root of 24, m to the 7th, maybe? Yeah, why not? N to the 7th and n to the 4th. Yeah, why not? All right. Break down 24. Let's do 12 and 2. Why not? Then we have 2 and 6. Then we have 2 and 3. I'll be honest, sometimes I break down into groups of 2s. I always have a bunch of 2s, usually my problem when I'm doing it, just to make it easier, especially if it's even. So you have 2, 2, 2, 3. You have 7 m's, 1, 2, 3, 4, 5, 6, 7. 4 n's, 1, 2, 3, 4. It's a cube root, right? We're circling groups of 3. So we have a group of 3 2's here. Boom, 2's going to be on that side. We have a group of 3. There's another group of 3. So you're going to write m to the 2nd power because there are 2 groups of m's. And then you have these group of n's right here. Everything else stays on the inside. So we have a 3 on the inside, an m on the inside, and an n on the inside. Okay? Because that's what you did not circle. Whatever you did not circle stays on the inside. All right, let's do, I wanted a bigger number than that, I'll be honest with you. I kind of wanted a much bigger number than that. Let's do a square root again. Now, even though there's not a number right here, there's always an imaginary 2 right there. So let's think about this. Let's do something a lot bigger. Let's do square root of 48, x to the 4th, y to the 7th, okay? Now, even though there's not a number right here that tells you what kind of groups what groups you're circling, there's always an imaginary 2, like an implied 2, because it's a square root. You're circling groups of 2. So let's break down 48 real quick. Let's do 16 and 3. 16 will be broken down 4, 4. This would be 2, 2, 2, 2. So you have 1, 2, 3, 4 2's. 1, 2, 3, 4 2's. And a 3, and a 3. Square root over here. Let's see. We have 4 x's. 1, 2, 3, 4. We have 7 y's. 1, 2, 3, 4, 5, 6, 7. All right. Put some little multiplication symbols in there just for fun. All right. Now, even though there's no number up there, remember, you're circling groups of 2. So let's see. Here's a group of 2. Here's a group of 2. Okay, now you have 2 groups of 2's. You can put 2 to the 2nd power, but we know 2 to the 2nd power is 2 times 2, which is 4. That's why you have that. You end up multiplying whatever you have on the outside, okay? Now, oops, I almost made my square root. Okay, let's see. We have group of 2, 2. So we have 2 x's there, so it'll be x squared. We have 1, 2, 3 groups of y's. And the rest of that stuff stays on the inside. So you have 3 right here. And then just a y. That's all you have on the inside. You're done. Hopefully this makes a little bit of sense. The only thing that happens sometimes if you have a negative in there, which I'm not going to throw at you quite yet because it's just the kind of the introductory of this. The one thing I was going to say, though, is if you do have something, let's say you don't have anything left in the square root or the cube root or whatever kind of roots you have, then in that case, you wouldn't even need to write this part right here that I just circled. Like imagine if that 3 wasn't there and that y wasn't there, you wouldn't even have this. You would just have this as your final answer, okay? Just so you know, we'll do something like that together in class too. But at least get this introductory thing written down so that way we can kind of, when we get to do this together in class, we can kind of get a bigger feel of it, all right? Okay, hopefully that helped a little bit, and yeah, talk to you later.